Start the recording. All right, cool. What up, dudes? Do you have a big need to see my face, or are you guys good? Nah, you know what? You're big kids at this point. Let Mr. Dalday doesn't need to show his face. All right, so check us out. Here's what we've got. In chemistry and in most sciences, we talk about mass, and that's a really important topic. But one of the things that is really important for us to do is to calculate out the density of a material. Why is that? Well, because the density is a property of the material itself. In fact, a lot of times, and this isn't in the textbook, but I'm just letting you know now, a lot of times your density is going to be given by this funny looking P thing. It's called a rho. R-H-O. It's a Greek letter. So you might not see this in the textbook, but in college lectures or something like that, or maybe if you watch chemistry videos, you'll see them write down rho. All right. Now rho is equal to mass over volume. Cool. And mass is measured in grams per centimeter cubed. That's what we usually measure it in. We could measure it in different volume. We could go kilograms per meter cubed, or kilograms per centimeter cubed, or whatever, as long as we have the units of a mass up on top and a volume on the bottom. Are we cool? Yep. All right. There was something that I want to do with you folks, and it was one of the homework problems, and you were asking me about that, and it's not that I forgot. It's that there was a subtle trick that you needed to do, and maybe you might have figured it out. Maybe you might not have. But I'm going to make up a problem for you, and I want to show you folks how to do it. Okay, let's do this. Let's convert. Let's get the volume of a box. And let's make it a 3-inch box by a 4-inch box by a 5-inch box. Okay? And I'm only doing this with you kind of to prep you for this idea of volume. It gets a little tricky. I want to convert this. All right, tell me, what is the volume of this thing? You guys know? 60 what?
Meters squared.
60 inches cubed. Yeah. Right. Because it's 3 inches times 4 inches times 5 inches. That wasn't hard. Good. 60 inches cubed. Awesome. Now, if I were to ask, oops, I'm sorry, I didn't want it in inches cubed. I wanted it in centimeters cubed. Or I wanted it in meters cubed. Then what you would do is you would say, okay, fine. 60 inches cubed. Well, I know I'm going to make that little table looking thing that you guys have learned to hate so much. And I'm going to say 1 inch is 2.54 centimeters. So you multiply 60 times 2.54. Use your calculators, please. I'm going to guess that's what, like 150 something? 152.4. And I would say my answer is 152.4. Actually, I'm going to take off that thing. There. 152.4. Does everyone agree? Everyone agree with that? Yes? No? Yes, yes. Awesome. Okay, good, good, good. Mattson. All right, Mattson saying, hold up. Waiting. Waiting. Do you agree with it now? All right, Madison says yes. Awesome. You folks are all wrong. Completely wrong.
Wrong.
Yeah. Absolutely wrong. The reason being is because what you did was you took this inches cubed. You know how I like to do this canceling game? You have 3 inches cubed. You have an inch times an inch times an inch, and you only divided it by 1 inch. So it's almost like x squared divided by x. or x cubed divided by x. All you did was turn that into an x squared. You still have an inches squared over there. Does that make sense? What you'll have to do is you have to go 60 inches cubed times 1 inch for every 2.54 centimeters, 1 inch for every 2.54 centimeters, and 1 inch you have to do it like that. You'll have to do that 3 times. Does that make sense? Because this inch and this inch and this inch makes it inches cubed on the bottom. Do you agree?
Yeah.
And since I'm multiplying all these out, so inch, inch, inch makes it inches cubed on the bottom, and that will cancel out with this. And then the centimeters times the centimeters times the centimeters. We're just looking at units. If I have centimeters times centimeters times centimeters, what am I going to have in the end? Centimeters cubed. So what I want you to take is 60 times 2.54 times 2.54 times 2.54. And what did you get? $983.2. And also, just to keep in mind, I gave you the answer as 1 sig fig here, 1 sig fig here, 1 sig fig here. So that your answer has to probably only have 1 sig fig in the end. I would say that this is like 1,000 centimeters cubed. Technically, this is the answer your calculator gives you. This is the answer I expect for you to write down. Because I expect for you to understand significant figures. You got to go back and say, well, how many significant figures did I have at the beginning? And then write that down. Are we cool? But essentially, this is kind of the idea that I wanted to cover with you. Now, the way I told you to do your homework is when you folks asked me that and you were doing your homework, I said, oh, just convert this to a centimeters, this to a centimeters, and this to a centimeters, and then multiply it out and figure out the volume. You'll get the same answer, believe me or not. And I don't know if you believe me, but I mean, you'll get the same answer. You can actually make that big, you know.
I made it smaller.
Oh, okay. Are we cool with that? You don't get number 1. I'll tell you what. Why don't we finish off my talk on density, and then we'll do number 1. Cool? All right. A certain mineral. Okay, let's see. Let me zoom out. There we go. Let me make this big. Let me zoom back in. All right, here we go. A certain mineral has a mass of 17 grams and a volume of 2.5 or 35 centimeters cubed. What is the density? All right, density is mass over volume. The mass is 17.8 divided by 2.35. This is grams per centimeter cubed. I don't know, you just plug it into your calculator. 7.57 grams per centimeter cubed. Done. That was easy. All right, here we go. What is the mass of a 49.6 milliliter sample of water, which has a density of 0.85 grams per milliliters? Okay, so density, here's the equation you should write down. Density is equal to mass over volume. And they want us to figure out what is the mass of something, right? Are you paying attention? You're texting your girlfriend.
No. Girlfriend? I don't have a girlfriend.
Well, you're texting somebody.
I'm listening.
Or you're texting your mom. Which is a little weird if
I'm
I
not
called you
texting
your
my
girlfriend and just it was actually your
No,
mom. So
no.
that's all right.
This is all they stop.
All right. I'm just saying.
Okay.
Dude, I'm letting you know that if you're all like texting somebody while I'm gonna give you a hard time about it and embarrass you, so that way you don't do it.
So it's just getting uncomfortable.
Yeah, no, I know. Hey, we're friends here. All right, anyway. Density is equal to mass over volume. You want to solve for the mass. All you do is you multiply both sides by V. This cancels that, and you get the mass is equal to density times volume. So all I got to do is just say, all right, fine. What was the density they gave me? They said the density was 0.85 grams per milliliter. And the volume is 49.6 milliliters equals mass. So my mass is 42 grams. Actually, can you multiply 49.6 times 0.85 for me? I want to know what the answer is. Okay, these questions are straight out of my presentation. So these aren't from your homework or anything. I can solve a problem for you in your homework, but I figured I'd do these ones. What is it?
42.
All right, so the answer is actually 42.16. But here's my question. Why did I write down just 42? Yes, that rho, the P-looking thing is actually a rho, and rho means density. I remember rho from there's this book or there's this movie on Netflix called The Book of Kales. Have you ever heard of that? It's a cartoon. It's pretty awesome. You should watch it. It's called The Book of Kales, and it's about these monks writing. They would draw these beautiful pictures, and one of the things that they would represent for Jesus Christ would be this symbol right here. I don't know if you've seen that at all. That's called the chi-rho system, or the chi-rho, and what it represents is chi as in or like CHR. So that's the chi is the Greek letter for Christ, and then the R represents the R in the Christ, so it's chi-rho. All right, I don't know. It's a little weird. Anyway, if you look up online chi-rho, CHIRO, RHO, there's these beautiful pictures that these monks would draw, and they felt like if they were to draw this thing, they can get closer to God and whatnot. Anyway, that's where this stuff kind of comes from. Is this rho is actually a Greek letter that we use when we want to talk about the property of something, and density is one of the first properties that you're introduced to in chemistry. Believe it or not, I see this rho pop up other times when we talk about and I won't talk about it in this class, but I'm just letting you know later on in a higher level chemistry class, or you'll talk about the efficiency of an object and its ability to conduct electricity or something like that. A lot of times we give that property we say rho, but then we give it a little subscript like Z or something like that. And immediately when I look at that, I say, oh, that's a property of that material. Anytime we use the symbol rho, it seems like we're talking about a property of that material. So what's nice about it is you can actually figure out what type of material you're dealing with if you have the density, because the density kind of is a telling factor of what it is you're dealing with here. By the way, we didn't answer my question. I kind of got into a divergence, but if the answer is 42.16, why did I only write down 42? Because the original problem only gave me 2 sig figs. It gave me 2 sig figs and 3 sig figs, and since I'm multiplying them, I limit it down to the one that has the stuff. Also, according to the Hitchhiker's Guide to the Galaxy, it's the answer to everything.
42.
42. All right, anyway.
I love that movie.
Yeah, I never watched the movie, but I read the book.
The book's good.
You got to be you can't really claim to be a super nerd, and which is what I'm claiming to be, unless you read the book. All right, anyway. A chemist is trying to identify an unknown liquid. He finds that 25.00 centimeters cubed of a substance has a mass of 19.625 grams at 20 degrees centigrade. Of the following densities of compounds, what might the liquid be? Now I got a question. Why do they need to tell us the 20 degrees Celsius? It's an interesting question. Why do they need to tell us the temperature at which they measure this thing at? That will boggle your mind. Does any of you drive yet?
I can drive.
You can drive? Do you fill up gas?
Yeah, sometimes.
All right, when you fill up gas, they actually tell you that we're not liable for how much gas you get if it's a hot day.
Right.
And why would they say that?
Evaporation.
Because most gases or even liquids. Now, water is a very interesting one. Water is a very weird substance, even though it's the most common one and important to us.
It changes.
Yeah.
With the temperature.
As the temperature changes, your volume changes. Does that make sense?
Mm-hmm.
But your mass doesn't change. I mean,
Takes a
how's your
lot.
ice cubes going to get heavier inside the fridge as they get bigger? That doesn't make sense. So what they need to do is they need to tell you the temperature at which something is, which 20 degrees Celsius is about room temperature, and then they'll tell you, okay, this is the density of this object at that certain temperature. Because maybe the density will change depending on if the temperature were different. Does that make sense? All right. Anyway, all they're asking us to do is find the density. Oh, that's easy. 19.625 grams divided by 25.00 centimeters cubed. Someone give me an answer. What is 19.625 divided by 25?
0.7850.
0.7850. 0.7850.
I don't think so.
Wait.
Look in the book.
You're looking at the book, you cheater. All right.
Oh, yeah.
Yeah. All right. Good. Yeah. This problem comes straight from the book. Yeah. That's right. All right. 0.7850. And I would limit it down to, well, actually, I would write down exactly that, 0.850. Because there's 4 sig figs here. There's 5 sig figs here. So, I would write down at least 4 sig figs. All right, 0.850 means I must be dealing with isopropyl alcohol. That's some good stuff. All right. Now, you know what's really interesting? And I'm going to tell you guys this. Here's my story that I kind of want to do a experiment on. However, I don't know if they'll let me because this is a school. But I'll tell you folks this, and I know this is on the recording. Don't give away this story because it might get me in trouble, and I don't want to get in trouble. I'm already in enough trouble as it is all the time. All right. One of the things I noticed when I used to go out to a club is, yeah, believe it or not, Mr. Dalde was cool at one point in time and actually went to a clubs. One of the things I noticed when I went out to a club is that one time I had this friend, and she was a female, and she's really good looking, and so guys, and we were just friends. I had a girlfriend at the time, so I was friends with this other girl, and so we were out at the club, and then this guy bought her a drink, right? And right before she drank it, I looked at it and I said, "Hey, don't drink that." And she goes, "Why?" And I said, "Well, look where the ice cubes are." And she was actually a chemistry major at this point. So I said, "What?" Look where the ice cubes are. And the ice cubes, what do they do in water? What do ice cubes do in water?
Melt.
Well, they melt, but they float. Exactly, they float. But alcohol is less dense than water.
Right.
So what does alcohol do, or what do ice cubes do when they're in alcohol? They kind of sink. Now, the drink that this guy bought this girl the ice cubes were just flat out on the bottom of the jar. That means this guy bought her like 120 proof alcohol and was just trying to full on get her like hammered wasted. And you can tell by looking at the ice cubes. You can look at this thing and be like, hey, the ice cubes are at the way bottom. That means that there's more alcohol in this thing than water. That means don't drink it or you're going to be like plastered, completely gone. Does that make sense? So, I saved my friend's life. Anyway, I don't know if I saved her life, but I'm just saying, like, that would be an interesting lab to do. Although I'm not sure if they'll let me bring in alcohol and mix drinks and
Maybe we
all
can
that
just
kind
get
of
the
stuff here.
teachers wasted and see what happens.
Yeah. These teachers like drinking alcohol. I don't drink anymore, by the way. Yeah, it's funny. I drank like right before college, and then right after that, I stopped. And I can tell you how many drinks I've had since I turned 21 on two hands. I can tell you.
Wow.
Yeah, I had like 8 all together.
Wow.
8 glasses of alcohol since turning 21, and I'm old. I'm old like dirt. So anyway, yeah, I don't know. It just after a while, it just started tasting like terrible, And I guess I got to the point where I was comfortable with how nerdy I am, so I didn't need to prove how cool I was anymore. And so I was just like, I'm gonna own up to it. I'm a nerd. That's cool. And so I didn't need to feel the need to be pressured by drinking a lot and going out and partying, because I was like, I'm not gonna be cool anyway. I'm a nerd by trade. And guess what? I still got a wife and everything, so I'm happy. All right, anyway. Anything occupying space has mass. Is there anything that doesn't have mass? Is there anything that doesn't have mass? Gravity.
Air.
No, air. Air has mass. Air has a lot of mass, actually.
Yeah.
Believe it or not. In fact, air has so much that if you were to take a column of air that is 1 inch thick and it goes all the way up to the atmosphere, it would weigh 14 pounds.
Huh.
There is 14 pounds per square inch pushing on your head right now. Per square inch. And you've got a big head. That means even more.
It's a beautiful head.
Yes, it's a beautiful big head. Anyway, there are 3 states of matter. There's solid, liquid, or gas. There's actually a 4th state of matter. Actually, to be honest with you, there's like 8 states of matter. But to kind of keep your brains, not explode them for now, I'm going to let you know that there's solid, liquid, gas. There's also plasma. There's this other one called a Bose-Einstein condensate, and all of those kind of things. Those are pretty crazy stuff. But for now, just know that there's solid, liquids, and gas. Cool? Now, in solids, liquids, and gas, I taught this lesson to students who were like middle school and whatnot. The solids, your atoms are basically connected like this, and they're pretty rigid as far as like the connection in between them. Cool? And then the liquids, those atoms, they're kind of loosey-goosey. They're kind of like hanging out, right? And then the gas, those atoms are just bouncing off the container walls, just all over the place. Are we cool with that?
Yep.
All right. So really, the solid, liquid, and gas depends on what type or how the molecules are connected. If it's a solid, rigid connection, then you have a solid. If it's a kind of like a still connected but not very heavily connected, then you'll have a liquid. And if they're just bouncing off of each other, then you have a gas. Yes, I will do homework sample problems. Let me tell you a little bit more about some other things. What other information are we covering?
You mean you'll help us do our homework?
Yes, by homework sample problems, I mean I'll help you do your homework. All right, a solid has a fixed volume and shape. An ice cube, all right, and the way I taught that is if I took a big container and I put an ice cube in it, would the shape of the ice cube change? Not eventually, I'm just saying a frozen ice cube and I put it inside the freezer or whatever. Would the shape of it change? No. No, it'd just be an ice cube inside of a cup.
Oh, and
The shape of the ice cube would still stay the same, right? Even if I put it in a weird looking cup, like let's say a cup that looks like this, the ice cube would stay the same shape. Does that make sense? All right. What if I took water and I put it in a cup, even a weird looking cup like this? What would happen?
take the form.
It would take the form of this thing. It would kind of fill up all of the gaps over here. So would the shape change? Yes, the shape would change. It would change the shape to fill up exactly whatever the volume of the container would be. Or not the volume, but the shape of the bottom of the container. Would the volume change? Can the volume change?
Yeah.
Who are you texting? Can the volume change?
It can.
Not really.
Not really. Can it somewhat?
It can very, very small, slightly, but not really. The volume does not change. You cannot push water together and compress it. In fact, that's how hydraulic jacks work.
Right. Yeah.
Is a hydraulic jack basically has like a jack right here, and then it has a water hose connecting it like this right here, and it's got a smaller jack over here that lifts up a car. This part lifts up a car, but basically you have it filled with water, and you push this side down, and then that water isn't going to get smaller or compress. Does that make sense?
Yeah.
What I mean by that is, think about this. What about a gas?
Water's
If I have a gas, can I change the volume of the gas? Can I compress a gas?
Yeah.
Yes, I can. Because remember, think about how those gas molecules are connected. They're bouncing off of each other, like this. So if I take a container and I put a cap on it and I push that cap down,
they'll start to get.
well, they'll just collide more often. But I won't have a.
It'll be more.
It would just have a higher pressure.
Smaller.
Sure, it will have a higher pressure, but will the volume change? Yes, the volume will change. The shape will change.
Right.
It takes the shape of whatever container it's in, and the volume changes. Does compression make a new gas? No, it doesn't change anything inside of it. It will actually.
It's not changing the construction.
In fact, actually, believe it or not, if you compress it enough in the right way, you can actually turn it into a liquid.
That's cool.
Anyway, you can even turn it straight to a solid. It makes a physical change, but it doesn't make it doesn't change what kind of stuff you have in there. It's not a chemical change. All right, well, let's talk about this because I think this is important, and I'm not sure if I made a slide on this one. Very good. Homogeneous mixture versus a homogeneous or a heterogeneous mixture. Okay, a homogeneous mixture.
I remember this.
Okay, 1 second. I've got my phone call. Let me hang up on this one, and then I'll answer later. That's my wife. Better not hang up too much. All right. A heterogeneous mixture to me is like a classroom in Hawaii. I like that. It's trail mix, right? You look inside of this bag of trail mix, and you can see all different kinds of stuff inside there. Does that make sense?
Mm-hmm.
All right. So, what if I took that trail mix, took a cup of it, of trail mix, put it into my Vitamix, and I blend it. In fact, I didn't even put it in my Vitamix. Put it in my Vitamix, blended it for 2 hours, and then I put it into a juicer. It would taste terrible, by the way, but I put it into a juicer, and what comes out is this like sludge of stuff. But could you distinguish between the peanuts and the M&Ms and the raisins that were inside of there? No, it'd all be this kind of brown mush. You guys get it?
Yep.
That would be a
That's
homogeneous
disgusting.
mixture. A homogeneous mixture means kind of the same. You can't distinguish between the two.
It's not genus, it's genius.
What do you call it? Homogeneous?
I say heterogeneous or homogeneous. Genus.
I've always learned it as genius, but I mean, I don't know.
Oh, that's how
Alright,
she always said it.
Let's go ask. Hold on
I
a second.
say genus and
Hey, Mr. Nonini,
Is it?
is it heterogeneous and homogeneous, or is it heterogeneous, genius, and homogeneous?
Do you say genus or genus?
Heterogeneous
And homogeneous.
Yeah.
Oh, okay. I say homogeneous.
Genius.
I'm sure I'm pronouncing it wrong. You're right. It's homogeneous is the right word. It's homogeneous
Thank
and.
you.
But it is, what is hetero? Heterogeneous or it's not heterogeneous, right?
Heterogeneous.
Celeste, we need your tiebreaker.
Celeste.
Celeste,
Celeste, the biologist.
Celeste, tiebreaker. Homogeneous or homogeneous? All right.
Ha.
Heterogeneous or heterogeneous? See, I said heterogeneous. Booyah! In your
No, I
face.
was
Close
half
the
right.
door.
I was half right. No.
oh, that breeze.
heterogeneous. No, it's it's
I felt good.
heterogeneous
And
and homogeneous. Homogeneous. Anyway, a homogeneous mixture. A homogeneous mixture is something like milk.
Comments.
Milk is a homogeneous mixture. Anyway, yes.
Like we
Homo
would
means
know.
same. Hetero means different.
Well,
right.
homo means a couple things.
Yeah, but well,
No, it all means same. Yeah,
yeah. Even when you're talking about like
same sex.
sexual
Yeah.
preference, it's homo means the same, right?
I mean, there's a slang meaning.
And heterosexual means likes different people than the same. That makes sense to me. All right. Anyway. Okay. Let's see. I'll tell you what. You folks can read descriptions. I'm not going to go into those with you. I'll tell you what. Why don't we do this? Why don't I spend the rest of this time going over homework problems with you and talking about them? Cool. All right. Now you guys are asking a lot, and let me see if I can find them for you.
They really want you to do their homework.
Yeah, they really want me to do their homework for you. And you know what? I usually have a problem with that, but chemistry is so much that I don't mind doing one or two. All right. Okay, what did you want? Which one did you want? Which one was due? All right. Bianca's
Homework
still asking
density.
for 4 and 5 in density.
Chapter 1.
I'll tell you what, I'll take a look. Density, Chapter 1, preview. All right, here we go. Question 4. A sample containing a 33.42 metal pellets is poured, or grams of metal pellets is poured into a graduated cylinder containing 12.7 milliliters of water, causing the water level to the cylinder to rise to 21.6 milliliters. Calculate the density of the metal. Oh, okay, good. How do we measure the volume of a substance? What if it's an odd-shaped volume? What if I wanted to measure the volume of a, I don't know, a pen? What do you do? Like if it were the volume of your shoebox, that'd be pretty easy, right? I would take the length times width times height. But if I wanted to measure the volume of a pen, what I would do is I would take some kind of like measuring cup. In this case, in chemistry, we call them graduated cylinders. And I would put water inside of it. And then I would put my object inside of that. Let's make it a pen. And that would cause my water to rise like that. And then I would know that the difference in the volume of water would tell me exactly what the volume of that thing was that displaced the water. So it's telling me that the water height over here was 21.6 milliliters. And it's telling me that your initially started at 12.7 milliliters. So somebody help me out. What is 21.6 minus 12.7? I don't keep a calculator on me. I really should.
You're a math teacher.
Yeah. It's your turn to... All right, 5.9. 5.9? What?
Wait, what? No.
That doesn't sound...
Can you say it again?
8.9. There we go. 8.9. 8.9 milliliters. I agree with you. All right. So calculate the density of the metal. Okay. So that would be 33.42 grams per 8.9 milliliters. All right. Someone plug that into your calculator. 33.42 divided by 8.9. And I'll be honest with you, I could have just screwed up the answer. That's always a possibility.
Which one are you doing?
This is number 4.
3.7.
Do you get 3.7? All right.
3.78876.
78864? Somebody got 3.755. 3... Well, anyway, I'm just going to write 3.8 grams per milliliter. Why would I just write down 3.8? Well, there were 2 sig figs to begin with. So, you know, what am I going to do? That's two sig figs. So anyway, 3.8 grams per milliliter. And then what I'm going to do is I need to convert this milliliters to per centimeter cubed. Now here's the question. We got to go look up inside of some kind of conversion table. What is how is milliliters related to centimeters cubed? Someone looked it up. Google that.
Milli is 1,000.
Google that. I know the answer off the top of my head, but I want you to Google it because I want you to be able to find
Am
the
I going
answer.
in the right direction though?
What?
Centi is 100, milli is 1,000.
Yes, but how many milliliters in 1 cubic centimeter? Look that up in Google. What does it tell you?
Wait, what?
How many milliliters in 1 cubic centimeters?
1 milliliter.
1 milliliter per every cubic centimeters.
Yeah. So they're even?
So I'm going to convert this.
They're even?
1 milliliter
It's a 1
for every 1 cubic centimeter. Yes, they are even. In fact, that is how we define a milliliter. In fact, that's how we define a liter.
Oh, that's right. I learned this
We
summer.
define a
Right.
milliliter by
I forgot
taking
about this.
a little cube that is
Yeah.
1 centimeter cubed by 1 centimeter by 1 centimeter, filling it up with water and saying, hey, guess what, folks? This is a
I
milliliter.
can't believe I forgot that. Yeah.
Yes, they're even Stevens. So this milliliter cancels out with that milliliter. I don't need to multiply by anything. My answer is 3.8 grams per centimeter cubed. Now, here's what we'll do. Is that what you guys got? I'm going to take a look at the question and see if it gave you the wrong answer. I told the computer to say, ask for you to put in 3.8 with a margin of 0.1. So you could have put in 3.9 or 3.7 and I would have been happy. But officially the answer is 3.8. Now if the computer didn't tell you that's the same thing, I don't know why it did that. All right. Did you want number 5, which I'm assuming is this one?
Hermitude.
Is that the next one you wanted? Can you check 10 for 1.9? Yes, I'll check that. But let me just do this problem real quick, and I'll do another one. And then after that, I feel like I've given enough freebies. All right. The density of osmium, the densest metal. Huh. I've worked with rhenium, and that's the second densest metal. Anyway, the densest of osmium, the densest metal, is 22.57 grams per centimeter cubed. If a 1 kilogram rectangular block of osmium has the dimensions of 4 centimeters by 4 centimeters, calculate the third dimension of this block. Okay. Density is mass over volume. Good? And if we're talking about a block, volume is length times width times height. Do you agree? So, I would say that density is equal to mass over length times width times height. And it looks to me like they gave me the length and the width and they want me to figure out what the height is. Or maybe they gave me the width and the height and they wanted me to figure out what the length is. It doesn't really matter.
Sorry, I have a question. Do we put it in 3.8 cubic centimeters, or do we just put 3.8?
Well, I gave you the units. For what you're asking is for the previous problem.
Yeah, for 4.
Hey, watch me do the homework before you do the homework while I'm
No,
sitting
I
here.
was watching you do it, but I don't understand if we have to put in CM or just 3.8.
No, just put in 3.8,
Okay.
the numbers.
Okay.
Okay, anyway. So, this is 4, and we want to figure out what this is. This mass is 1 kilogram, and this density is 22.57 grams per centimeter cubed. Cool. Before I do that, let me just kind of work with this a little bit. I would say that if I wanted to solve for H, I would say H is equal to M over L times W times rho. Did I lose anyone there? That's basic algebra. Did I lose anybody there? Nope, you got that. Okay, all right, just making sure. You got it? All right, cool. So here's one step that I would like to take before I do anything. I think what I'm going to do is I'm going to try to convert the kilograms into grams. Oh, that's pretty easy. 1 kilogram is 1,000 grams. All right, so H is equal to 1,000 grams divided by 4 centimeters times 4 centimeters times 22.57 grams per centimeter cubed. That looks horrible.
I was about to say this.
Anyway, let's try it. Let's do the numbers. 1,000
times
divided by 4, or maybe, I literally like putting in the parentheses here. Do 1,000 divided by parentheses 4 times 22.57, close parentheses. And what do you get? All right. And while I'm waiting for you guys, I think it's 2.77 about?
Yes.
I'm just trying to do that in my head.
361,120.
Yeah, you did wrong. All right. 2.77.
Divide.
You
I
forgot
did divide.
what you forgot to do is you forgot to put parentheses around the stuff you were dividing.
Oh.
I can tell your screw up already just by listening to your answer and be like, yeah, I know what you did wrong. All right. Anyway, it's 2.77. If you guys didn't get that,
You have in me, Mr. Dolder.
no, it's not the faith I don't have in you. It's just that I can.
I know.
All right. Anyway, the number is 2.77. Let's look at the units to make sure. See this grams up here? It gets canceled out by that grams over here. You see this centimeter over here and this centimeter over here? What do those 2 centimeters give you? Those 2 centimeters give you a centimeter squared. Agreed? There's a centimeter cubed over here. So what I have is I have a 1 over centimeters squared divided by centimeter cubed. No, it's not centimeter 5. It would be 1 over centimeters. Yeah, I know. Out your head. I mean, think about it. Centimeters squared divided by centimeters cubed is equal to what? Is equal to 1 over centimeters, right? If there's two of them on top and 3 of them on the bottom, they cancel out. You're left with the 1 on the bottom left. Are we cool with that? Does that make sense to you? What does woot mean? W-O-T.
Woot. It's like woot woot.
Oh,
Yeah.
is that what it is? It's not like what? Ouch, the?
No,
Or something like
it's like
No,
yeah.
like woo woo.
Woot
All right, fine,
woot.
whatever. Okay. So you guys get this, right?
It's like hooray.
By the way, when I take a fraction and I'm dividing it by another fraction, what do? Do you guys know how to do that kind of algebra? You take the fraction on the bottom, you flip them upside down, and you multiply it.
I hate fractions.
I do too. That's why I like getting rid of them. So what I have is 1 times centimeters over 1. That's my units. Centimeters over 1 is also known as centimeters. So my answer is 2.77 centimeters. And look, the units worked out. So I know that's the correct answer. That would be my answer. 2.77 centimeters, my friends. And I think, let me check to see what I told you that the answer should be. I told Mr. Computer, give them the correct answer if they put in the number 2.77. Awesome. And I even gave you a buffer zone of 0.01, even though I technically didn't need to, because you should have put in the right answer in the first place. But you could have put in 2.76 or 2.78. Any questions, comments, concerns, vomits, etc.? You wanted me to check number 10 on section 1.9 or something like that? Confused, huh? All right. I'm sorry. I don't think that one was that bad, to be honest with you. Although I could be a big jerk, and Mr. Dalton saying, "Oh, that was easy."
It's just sig figs and PEMDAS.
Yeah, it's just sig figs and PEMDAS. And really, it's actually really hard, and you guys all feel like idiots, and you guys hate me because you're like, well, Mr. Dalton, you're really good at this because you've been doing this for 20 years, but I've been doing this for like 20 minutes, and this is really hard. And I'd be like, well,
I mean, you did just give us the answers to 4 and 5. So.
yeah.
You did.
I did just give you a lot of answers, so. All right.
Huh? You didn't know? That's what we were doing this whole time.
What is that?
2.77 is the answer for 5, and the previous one was for 4.
Anyway, here's what you can do. You can look it up on the archives and just watch the archives and get your homework done. All right. What do we got here? Match each description to the following microscopic pictures. More than one might fit the description. Okay. Give your answer to a gaseous compound. So which one is a gas compound? I'll be honest with you. This one's a little bit tough. I think that picture number 4 represents a gaseous compound.
What?
Because a compound is a mixture of 2 different kinds of elements.
What are we looking at?
And it's if this were all separated, that's kind of telling me it's a gas. This right here makes me think liquid or solid.
What are we looking at right now?
We're looking at states of matter. But I think that let's see, pictures 2 and 3. I would say 2 and 3 would also be gaseous compounds, but it also has a pure gas present. Does that make sense? So I would say that your gaseous compound would probably just be number 4. All right. So that would be that kind of homework. Let's see. The difference between a homogeneous and a heterogeneous matter. Classify each system or each of the following as homogeneous or heterogeneous. A door.
I still feel it's heterogeneous.
Is a door heterogeneous or is it homogeneous?
Homogeneous and heterogeneous.
I say it's hetero.
Hetero.
It's heterogeneous. Heterogeneous. It's hetero. Right? Right? Because the door is comprised of different things, right? It's not just this constant mixture, right?
Right.
Versus like B. Is B a homogeneous mixture or a heterogeneous mixture? Air. The air you breathe. Is that homogeneous or heterogeneous? Yes, I agree with you that the wood would all be the same, but maybe it might even be a mixture of different types of wood. So, and the doorknob is definitely
that
a part of
crappy
the wood.
stuff they make. Yeah,
But
like this stuff.
I would sure hope that the air that I breathe is homogeneous, because I don't want to see the different particles inside of the air that I'm breathing. So I would say homogeneous, hopefully, for my air. Got it? Let's see, for part D, the water that I drink. Also, I would hope that that's homogeneous. I don't want it to be heterogeneous. Salsa is heterogeneous because you can see the different things. I sure as heck don't want my water to look like salsa.
It's a horrible image.
Well, that's what I'm saying. I'll never forget that because that's gross. All right.
You want it to look like this.
Yeah, I don't want. Yeah, I want my water to be
becomes-
homogeneous because I don't want bits of floating stuff to be in my
It
water.
becomes heterogeneous when you start drinking it.
Why? Why does water become heterogeneous when you start drinking it?
Because parts of you go into it.
Parts of you go into the water? That's weird.
It is, but it's true.
All right, anyway.
Your DNA goes into it.
That's true, but I guess at the atomic level, then everything is heterogeneous because
We're
nothing is powder.
heterogeneous.
Well, we are heterogeneous. Your body is heterogeneous. Yeah, that's the next question is F, your lab partner. Homogeneous or heterogeneous? I kind of would hope that that would be heterogeneous, right?
I'd hope they're homo.
No. I'm not talking about their sexual preference. I'm talking about the...
I didn't.
Oh, did I say that that would be a homogeneous mixture? That is definitely wrong. People are not homogeneous.
People are not homo.
Homo sapiens.
Homo sapien. Yes, I remind me, Homo sapien.
Yeah, actually, I don't understand why we're called Homo sapiens then.
Same sapien.
Oh yeah, we are all sapiens. What? I don't know. Why are we called Homo sapien? What would it mean if a person were homogeneous? Well, you ever see that movie?
The binomial nomenclature for the human species.
You ever see the
Yeah,
the?
what is it?
Homo is a human genus.
You ever see the movie Monsters vs. Aliens?
What is binomial?
And they had that blue guy Bob, the gelatinous mass. I would say that would probably be. And human in a blender, yes, that would be a homogeneous mixture. Gross, Sophia, but correct. And you're right. I said the wrong answer. It's heterogeneous. Question F is heterogeneous. People are not homogeneous mixtures. All right, so here's what I'm going to do. I'm going to say, give everyone full credit for this question. Because I screwed it up. I gave everyone full credit for that question.
For which one?
It was like question 81F. Homogeneous mixtures. Okay.
Did you switch it?
Any questions? Yes, I switched the answer to the correct one, but it should give you the correct points for it.
I'm so confused. Which one is this?
This
We're
would
not
be
on
under the
density?
classification of matter. We're no longer on density. Does anyone have any other
Classification and
questions?
Separation?
Bradley, did you still need number 2 for the density questions?
Wait, can we go over what you did?
All right, fine. I'll do that last one, and then I'm done. Sound good? And then on Wednesday, I get to cover chapter 2. Although Wednesday we have a lab. I still need to figure out what your lab is. So, I'm working on that. But I'm actually going to have you come in. Okay, let's see. Question number 2 on density. Yes, a lab. Yes, if you are on Oahu, please try to come in for that lab. Question number 2. Is it this one, number 67? Is that what you folks are trying to do? All right, anyway, all right. A star is estimated to have a mass of 2 times 10 to the 36 kilograms. Assuming that it's a sphere of average radius, 7 times 10 to the 5th kilometers, calculate the average density of the star in grams per cubic centimeter. I admit to you, that's a tough problem. Let's do it. All right, you ready? 2 times 10 to the 36 kilograms is the mass. That's a massive star. All right. This radius is 7 times 10 to the 5th kilometers. Do you folks know the volume of a sphere if you were given the radius? You ever see the first Star Wars movie? The newer ones?
Yeah.
Yeah. They were showing this. They were showing this. No. This was like the first one when they had introduced Starship Enterprise. I thought it was good. I don't know if you guys liked it, but I thought it was pretty good.
I'm sorry, Star Trek or Star Wars?
Star Trek. I'm sorry. You're right. Star Trek.
Okay, you
Yeah,
said
you
Star
said
Wars, and then you were like
Enterprise.
Enterprise, and I'm like,
No, you're right. You're right. I'm sorry.
2 different genres.
I know. I'm just excited about the Star Wars movie coming out in
Yeah,
December.
me too.
All right. Have you seen the first Star Trek movie, the newer ones?
Yeah.
All right. Yeah. That
I'm
was.
looking forward
that
to
was
the
good.
third.
Yeah.
Maybe
Which is
the
why
third.
I was thinking the bad one. What are you talking about? Star Trek was pretty good, the first one, but then Star Wars, the bad one. Yeah, I agree with you. The first one sucked. Anyway, it was interesting to me when they showed this scene of all the Spock kids or the I don't know what are they called, the
Oh, they're doing all
Vulcans.
Vulcan
They were
children.
testing them, right?
Those were awesome.
That was
I wish I
cool.
was that
They
smart.
they were testing them inside of these little like half domes, right?
Yeah.
And you know what was interesting to me is these were supposed to be like this super advanced race,
Yeah.
and 4 times in the background I heard them ask the question, "What is the volume of a sphere?" And the answer is 4/3 pi r cubed.
Yeah.
And I'm thinking to myself like, wait a second, you're trying to convince me that this
This is,
alien
like,
race
really
is like
brilliant.
super advanced, and yet you've asked them 4 times what is the volume of a darn sphere? Are you kidding me? I mean, at least give them like, what is the volume of a trapezoid attached to a sphere? Or something like that. You know what I mean? Something tough, right? Something that I don't know in 3rd grade. All right, anyway. The volume of a sphere is 4/3 pi r cubed. So all you do is you take this radius and you plug them in there. 4/3 pi r cubed. Whatever that is. I don't know. Put in some numbers. Figure it out. Got it? Then you take that and you get your density because you now have your volume, which is this. And so you say your density is equal to mass over volume, which is 4/3 pi r cubed and whatever the r is. The hard part is now your units are in kilograms per kilometers cubed. And they want you to give it in grams per centimeter cubed. And I'll tell you what, I don't have time to do this, but I'm going to I don't have time to do this, but I'm going to say, refer to that very first problem I did at the very beginning of class when I said, hey, you need to be careful about converting kilometers cubed into centimeters cubed. What you're probably going to have to do is you're going to have to say, I don't know, let's pretend that your volume is 5 kilometers cubed. It's not, but let's just pretend, okay? Then I would say, and maybe let's make this 4 kilograms divided by 5 kilometers cubed. I'm just saying, let's just suppose. I'm making up some numbers because I'm too lazy to calculate out this or wait for you to calculate it. I can convert the kilograms into grams pretty easy. There are 1 kilogram for every 1,000 grams. That's pretty straightforward. The volume is a little bit tougher. What I would do is I would say, okay, there is 1 kilometer for every 100 or 1,000 meters. And I would do that 3 times. Why do I do that 3 times?
Oh, because
I've got the kilometer cubed.
Yeah.
Right, exactly. Yeah. I don't know what seabed is, but whatever. And then now I have meters cubed on the bottom. So I'd have some number meters cubed. So what I would do is I would convert that meters cubed into centimeters by saying 1 meter is 100 centimeters. And I would do that 3 times. All right, so I would take my answer, whatever my density is, I would multiply it by 1,000, I'd divide it by 100, or 1,000, divide that by 1,000, divide that by 1,000, divide it by 100, divide it by 100, divide it by 100, and that is my answer. It's going to be a very small number. Actually, it might be a big number, I'm not sure, because the density of a star is pretty big to begin with. I mean, look at that mass. 2 times 10 to the 36 kilograms? That's 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 kilograms. That's a big mass. But then again, it's also a big density too. I mean, it's also a big volume as well. So, we'll see. All right. Does anyone have any questions as far as
You know it's
things?
big when it needs
All right.
a second
And
row
then
of
the thing is,
You know it's big when it needs
in
a
this
row of
in this
anything.
particular question, I'm not looking for the number. I don't really care about the number. At this point in life, when you're talking about these huge numbers, the number part of it doesn't matter. What really matters is the exponent, the power of zeros. So I think the answer that I'm looking for is, what is your answer is going to be number times 10 to the 7 or something like that. I don't know, whatever it is, right? I'm looking for this number. That's what I'm looking for you to tell me what the answer is. Does that make sense? I hope that was clear. What is the power of 10 for the scientific notation for this number as measured in grams per cubic centimeters? I'm just looking for the exponent in the power of 10. How many zeros do I got to put on this thing? Negative zeros? 10 zeros? 100 zeros? Whatever. I don't know. All right. You got to go. I got to go. Let's go.
I have work.
I'll talk to you later.